This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session that is Big Data Masters program. And we are going through with distributed data processing with PySpark. In previous session, in last session, what we have seen certain aspect with respect to data optimization. Like we have gone through with write mode, and inside the write mode what we have seen different optimization technique, say partition by, bucket by, and compression. We have gone through with certain write modes as well, say overwrite, append, ignore, and error. And over there what we have seen, once we were using overwrite mode, then it is going to delete the entire folder or directory and then move the data with respect to the fresh execution. Whatever the query that we are going to execute, it is going to update uh, that particular path. Then append is going to refer that particular folder which is mentioned, and in that only it is going to append the new data with respect to new execution. Ignore, it is going to ignore if path is already exist, it is not going to perform any operation. Then we have seen error mode as well, and this was the default mode what we have seen. If you are not mentioning anything, it will be by default error mode. And over here, if the output path is already existing, it will throw error. So this particular stuff was with respect to the modes, write modes basically. As in the same fashion we were having a read mode as well, and we have gone through with read modes as well. And then we have discussed like partition by, bucket by, and compression. Partition by, and bucket by, these are the optimization techniques in order to minimize the amount of scanning. And partition is going to give you a folder, and this bucket by is going to give you a particular file. And what we have seen, the amount of scanned data has been reduced with respect to bucket by and partition by clause, which is available inside the PySpark. Then we have seen the compression codecs, and with respect to the compression codecs, what we have seen, there are two types of codec: optimized for speed and optimized for space. Or in other words, we can say process time oriented and storage size oriented. So once we are using process time oriented or the codecs which are optimized for speed, at that moment, like it might be possible that the space which is saved onto the disk, that might be less, but the performance will be fast over here. Okay, so based upon the use case, we need to go through, we need to choose but a particular codec for our use case, and then we can take the benefit. And the major decision point, what it will be, like optimized for speed or optimized for space. So then we have seen order by and short, like how to short the data. If like we are having certain data in a particular data frame, then what are the different techniques inside the PySpark which we can utilize for shorting the data? And order by and short, these are the two clauses which are available inside PySpark for shorting the data. We have seen order by and short both are working in the same fashion, but there is a difference. Like short is shorting the data based upon partitions, and order by is providing the universal sort. Okay, if you are you are having a particular file, short order by is providing you 100% shorted output. Respective of this, short is going to provide the outcome that is shorted based upon the partition only. Okay, partition levels shorting is short, and universal shorting is order by. So in big data world, like as we are having multiple partitions, the data is divided into smaller chunks, and chunks level sorting is done by short. So short is the performant one, and we are going to refer short in order to perform our operation. Then we have seen like data visualization related stuff, and we have started this particular topic. We will go through with this like data visualization in order to have the data visualization onto the refined data or meaningful data that we got after processing on Spark data frames. So certain meaningful data, we are going to apply data visualization in order to do the data analysis. So this particular stuff we will cover, but let me start the day with file formats. File formats. Yesterday we were discussing about file format, and file formats are playing a very critical role in big data world. Okay, so once you are going to design a particular product, then the fundamental question that will come in your mind: in which file format you are going to process the data, or what is the file format that we are getting, what is the format of file, incoming file format that we are getting. So those particular things are, you can say, with respect to the file format, and what I have mentioned, it is playing a critical role, because these particular file formats can boost the performance of the system, or you can minimize the latency with uh, choosing a particular good file format. So file formats are, you can say, good to know, and that's why like we are moving with file format related stuff. So if we talk on a broader level, uh, then there are two requirements. Requirements like, say, faster read, faster write. Okay, so like what we are having, say we are having data ingestion, then processing, then we are writing output to disk or any data lake or data warehouse, whatever, DW and database. Okay, so we are having a particular data that we are going to ingest. So over here, like we need to take input regarding the file format. In which format we are going to have the ingestion, then we are going to process onto that particular data that we have ingested. Now the processing has been done, and once the data is processed, then also like we need to store it in a particular file format. In the same fashion like what we have seen, say over here, just have a look onto this particular code. So what we are doing over here, we are reading the data in CSV format. This was the code that we have executed yesterday. So we were reading the data in CSV format, and then we were writing, after like certain execution, we were writing it in CSV format, and that's what like we are able to see over here. Okay, we are reading, like we are ingesting the data, and we are dealing with certain file formats, then we are processing it, and once we are able to process, then we are providing the or writing the data in a particular file format. But what is the decision point over here? Like, do we need to have faster read, over here, like do we need to do faster read, or do we need to do faster write? Okay, so those particular things we need to discuss over here, like which file formats are providing faster read and which file formats are providing faster write. Then another things requirement with respect to file formats, let me mention requirements. So it might be faster read, faster write. Then another stuff that is like splittability. So in big data world, what we are having, we are going to divide a particular file into smaller chunks file. Then we are having chunks, and then performing operations onto chunks, performing operations on chunks. Okay, so splittability is a feature, or uh, that is a feature, or you can say a characteristic of a particular file format. uh, is it splittable in nature or not? If a particular file format is splittable in nature, then we can divide that particular file format in chunks, and then performing the operations onto the chunks, and then uh, combine the output. Okay, so it will not have any issue if the file format is splittable, because what we are having, say, if we are having 100 node cluster, and we are not going to provide a particular file, uh, you can say a single file to that particular 100 node cluster. We are going to divide that particular file into smaller chunks, or smaller blocks, in you can say, and those blocks will be processed inside the multiple machines. And once, like, those particular chunks are processed, then we are going to combine the output uh, by taking the intermediate output from all the machines. That is what is happening. So if a particular file format is splittable in nature, then we will be able to perform these particular operations uh, in an easy way. But if, like, the file format is not splittable in nature, then it will be having a sequential process, like certain machines or certain nodes will be working on to top of that particular data. And uh, once, like, that particular node is able to process, then it is given to the another machine that will process on to top of that particular, you can say, output, or output data frame, whatever. And then at the end, like, we will be able to get the final output. But that particular thing will be sequential in nature. So splittability is a desired characteristic once we are dealing with big data world, and the file format must be splittable in nature. Then certain other characteristics are schema evaluation. Schema evaluation. So it might be possible that the schema of an incoming file, okay, that can be, you can say, changing on, you can say, frequently basis. Say today I'm having 10 columns in the data set, and tomorrow, like, it might be 9 columns, or 13 columns, or 14 columns, might be 20 columns, and day after tomorrow it might be, say, 25 columns. What is happening over here? The schema is not fixed over here. Schema is keep on, you can say, hopping. So at that moment, like, if we are having certain data, incoming data set, that is having certain change in schema, then we need to have certain file formats which can have good schema evaluation. Like if the schema is keep on changing, then the file format can be able to accommodate those particular changes. So schema evaluation is there. Then compression. Compression, we have gone through with compression. So compression is also a particular characteristic with respect to certain file formats. Some file formats are providing good compression, and some file formats are, you can say, providing good schema evaluation. Certain file formats are providing faster read, certain file formats are providing faster write. So compression is also a characteristic. Like once you are going to choose a particular file format, then you need to think what is your prime need. Faster read, fast, like these are the fundamental things. Say faster read or faster write. Then we are having certain sub points like splittability, then schema evaluation, and then compression. These are, you can say, secondary things that we need to, if like these particular things are there, or if we need to talk about these particular things, then that will be good to have. Okay, fundamental thing is faster read and faster write. Then secondary stuff like splittability, schema evaluation, and compression. Now these are certain characteristics which are, you can say, required from a particular file format. Now if we talk about file formats, then broadly there are two types of file formats. Types of file formats. And this particular, you can say, session is uh, good for interview perspective, or important for interview perspective. So try to pay attention over here. In each and every interview, one or two questions will be there from file formats. So what we are discussing, type of file formats. So there are two types of file formats: row based file format and column based file format. Okay. So row-based file format and column-based file format. In order to understand these particular things, let's proceed with an example. Okay. So say we are having certain data. Let me close this. Hmm. Okay. So let me copy this particular stuff only. So we are having this particular data. Okay, student ID, name, age, salary. Okay, address, street, city, and state. This is the information that I'm having in a particular file. Now, in order to get the understanding about these particular file formats, we are going with this particular example. Now, if I need to store this particular file, first I'm going to pick, say, row-based file format. Row-based file format. So row-based file format. Okay, row-based file format. Now, once I'm going to store this particular data onto disk, then how it will be stored onto the disk? So it will be stored like, say, how this data will be stored on disk. Okay, it will be stored like one, then say Swati. In case of row based file format, then 30, then 60, then this particular address. Okay, then room, Nagpur, then Maharashtra. Okay, so this is with respect to the first record which is available in this particular file. Now I'm having the second record, then how it will be stored? It will be stored in the same way. Once after another, then say Rohit is there. Rohit, then 38, 38, then say 76, then this particular information, then room 602, Delhi, Delhi. Okay, if say I'm having another record, say if I want to insert certain data onto this particular file, so say the student ID 3, with respect to student ID 3, and the record say, let me mention say Shivam, Shivam is there, then say age is say 30, then package say 65, and salary that is, and let me mention this particular address with certain changes. Okay, and then this particular information, and Delhi, Delhi. Okay, let me try to mention it in this particular way for good understanding. Okay, so in this particular way, like the data is being stored onto the disk. Now, if you are able to see what I need to do, like if a particular new record is coming, then I'm just going to paste it onto like one after another. First record, then second record, then third record. In the same fashion, like I will be having fourth record. I'm just going to paste the data one after another, and in the same fashion it will be moved onto the disk. Okay, so what we have seen over here, like data write is faster over here, data write is faster. Okay, data write is faster in case of row based file format. There is like I'm just like going to insert the data, and it will be, you can say, moved onto the disk one after another. Okay, so no rocket science is there. So because of this particular reason, the write is faster over here. Now suppose I just want to get the information, say select, uh, say name, select name from say student data. This is the student table, say student table where say student id equal to say 2. Okay, so at this moment, what it will do, it is going to, like it is going to scan the, I'm just we are having over here the things are visible over here. Okay, pretty visible over here. And what will happen at this moment, say select name from student table where student id equal to 2. So what it will do, it will scan this particular record, then it will scan this particular record. So entire data will be scanned over here in order to get the records with respect to the student id too. Okay, it might be possible this student id is repeated over there. Okay, in this particular data set the student id say is repeated. So say it is repeated 10 times or 100 times, so what it will do, it will going to fetch the names of the student with respect to say student id 2. So what is there over here, like uh, I need to scan the entire data in order to perform this particular query. And because of this particular reason, data read is slower over here. Data read read is slower. Okay. Data read is slow in row-based file format. Data read is slow. That is. Now, that is fine. Data read is low, but what is happening once we are having this column-based file format? What we have seen, two types of file formats: row-based file format and column-based file format. What is happening once we are having column-based file format? How the data is stored once we are using column-based file format? So this is the column-based file format. Okay. So what is happening in column-based file format? If I'm having a particular, if I need to insert the data, so it will be inserted. Say I'm having student ID 1, 2, and say 3. Okay. Initially, I'm having two records only. So say 1 and 2, student ID 1 and 2. Then I'm having rest of the record. Say then Swati is there, then Rohit is there. With respect to each and every column, the data is maintained. 30 and say 38, then 60 and 76. Then this particular information and this particular information. With respect to each and every column, it is going to pick the data. Then say, let me enter Nagpur, Delhi, Maharashtra, Delhi. Okay. So in this particular fashion, the records are maintained onto the disk. Now suppose I'm having another record that I need to insert onto a column-based file format. Then what will happen? Say Shivam is there and Shivam ID is 3. So Shivam is, you can say, inserted over here. That is fine. Then say Swati, Rohit, and then Shivam will be there. Shivam. Okay. And then with respect to Shivam, 30 is the age. Say package or salary is 65 for Shivam. Okay. And for the Shivam, the address is this one. It will be maintained over here, one after another record of same type of, we can say from the same column. It's fine. Then what we are having this particular information, room 601, and over there. Okay, so let me mention the Delhi. So this Delhi will be over here, and this Delhi will be over here. So what is happening over here, once we are having column based file formats, then it is going to pick the records column by column. Okay, say first column record, second column record, third column record, fourth column record, fifth column record. In this particular way, it is going to maintain the records. Now, if like I'm having, I need to maintain this particular information, then definitely like I need to insert the data onto, say, like once I'm inserting the data in this particular way, I need to have the awareness like where is the first column record, where is the second column record, where is the third column record. That particular information I need to have. Particularly, I'm talking about column based file format. Previously, inside the row based file format, I just need to enter one after another. It is not going to like check another any column. It is going to insert the record onto the disk. But over here, column related information is maintained, and that's why write is slower in column based file format. Column based file format is having write slower because like we need to have this particular information, column based information, where I need to insert the new record. That is fine. Write is slower over here. But what is with respect to read? Okay, now I'm going to perform the same operation. Select name from student table where student ID equal to 2. Okay, so at this moment, this is the student ID column, and this is the name column. Okay, so this much of data will be scanned once I'm going to perform this particular query. It is not going to scan the rest of the data, and that's why data read is faster in column based file format. Okay, so just have a look friends onto this particular stuff like row based file format and column based file format, and if you got the understanding, then I want the confirmation from your side, and if things are fine, then we will move further. Just have a look and ask if you are having any doubt. Row based file format and column based file format. Swati, Rohit, Shivam, Vandana, Naresh, Rahul, Rajbabu. Row based file format and column based file format, is there any doubt?
No, sure.
No.
Sir,
Mm-hmm.
in row based is first read the complete row for one time, then it's come to second row, like that, no?
Inside the row based file format, we need to scan the entire data in order to get this information. Entire data, this complete data will be scanned, because
Okay,
over here what is happening, records are inserted one after another. It is not having information over here. It is going to scan, say, all the records with respect to student ID and all the records with s- name, but rest of the records will not be scanned. Rest of the records will not be scanned.
okay,
Okay, that's why like this row based file format, oh sorry, column based file format is much faster than row based file format. Over here entire data is scanned, and we know scanning is killing us, like if we are having huge amount of scanning in big data world, then we will be having high latency and we will be paying more. So we just need to think how to reduce the amount of scanning, and this is the way. If we are opting a good file format, then definitely we will be able to minimize the amount of scanning.
okay,
Okay,
okay, sir, okay.
so let me repeat it once again. Over here the entire data will be scanned in order to run this particular query, and over here in the column based file format, only this much of records, like 2 columns, will be scanned in order to get get the output of this particular query. And this is like the way how data is maintained onto the disk in column based file format, because like ultimately we are fetching from the disk only. Okay, another basic aspect, say uh, why column based file formats are preferable. So column based file formats are having better compression. File formats are having better compression if we compare it uh, with row based file format, no? Just have a look why compression is better inside the column based file format. Now over here the data is maintained with respect to columns. Over here, like we are having like there is no segregation, we are just like picking one row at a time and then like inserting it onto the disk, moving it onto the disk. No bifurcation is there. But over here, like if we are having the column level information, then what we will be able to do, we will be able to apply certain encoding over here. And what is happening with respect to encoding, friends? Say we are having this particular information, say Nagpur, Delhi, and uh, say Maharashtra. Say we are having 1 lakh record. 1 lakh records are there. Records. And say we are having state information, and we are having 3 states, Delhi, Haryana, and say Rajasthan. Okay, so 3 state informations are there. And with respect to this, you can think in this particular way, we are having 1 lakh records of people, like who are having a list of persons who are having salary package, say greater than say 50 lakhs. Okay, so we are having a particular list of persons from these 3 states who are having package greater than 50 lakhs, and we are having 1 lakh records of such people. Now 3 states, basically, like we will be having 3 state informations, and say data is there, like say name, age, age, say Aadhaar number is also there. Aadhaar number, say government of India has maintained this particular data based upon uh, like the income tax return file, and they have maintained this particular data, their Aadhaar number, name, age, and say salary. Okay, salary and say state information. So this is say the data set which is maintained by government of India with respect to these 3 states. Now like the data is maintained in such a way, say Aadhaar number, like this is the Aadhaar number for that particular person, and say name is say Ram, say age is say 20. Okay, salary is say 60 lakhs. Let me try to use certain tabs. And state is say . say Rajasthan. Say we are having another, we can say Aadhaar number, and say name is say Rohit, age is say 34, salary is say 70, and say state is Delhi. We are having say another person. I'm just taking certain example. Say Naresh, okay, age is say 30, package is say 65, and say Rajasthan. Okay, another person is there. Say Vandana is there. Age is say 29, package is say 70, and say state is Haryana. Then another person, in this particular way, like we have maintained the records. 30, package is say 70, and say Delhi. Okay, so we are having this particular data, say that we have maintained, that government of India has maintained with respect to these three states. Now they are using say column based file format, and how this particular data will be stored onto disk, like these particular, you can say, state will be there, like this, say state Rajasthan, Delhi, Rajasthan, Haryana, and Delhi. Okay, so we are having the information for this particular column, that is maintained in a single, you can say, in one go, like we are having this particular column information. Over here, just try to focus. So over here, what we can do, we can do certain coding. So what is happening, once we are going to store string information onto the disk, then string is going to take 2 bytes. String is going to take 2 bytes. 2 bytes on disk. 2 bytes on disk. Say like say R is there, that is going to take 2 bytes. A2, J2, A2, in this particular way, like we will be having certain bytes occupied onto the disk. Say if we are having Rajasthan, say 1, 2, 3, 4, 5, 6, 7, 8, 9. So Rajasthan is going to take 18 bytes. Strings it takes, let me mention, string takes 2 bytes on disk, and if Rajasthan is there, it is going to take 18 bytes. 18 bytes on disk. And if we are having integer information, integer integer is going to take say 4 bytes. 4 bytes. Integer information, whatever is there, like the range, a particular range is there with respect to an integer value, so that is going to say take 4 bytes. Now Rajasthan, this particular state information is there. Now how like the compression will happen over here, this particular state information will be like we can do certain coding, encoding over here. Say the very famous coding that we are having, say dictionary encoding. Dictionary encoding. So encoding, what we can do with respect to the dictionary encoding, say this is the key, say Rajasthan is a key, and we can have information say 0, then value 0, Delhi is there, and say the value is 1, and Haryana is there, and say the value is 2. So in place of Rajasthan, Delhi, and Haryana, we can have these particular values. So, in this particular way, we will be able to save huge space. Previously, say Delhi was taking say 10 bytes, and Haryana taking 14 bytes. Okay, Rajasthan was taking 18 bytes, and if we are going to replace it with dictionary encoding, then we will be able to manage within 12 bytes. Three records with 12 bytes, because integer is going to take 4 bytes only. So these, you can say, instead of say 18, uh, 14 plus say 10, so that is around 42, 42 bytes, and we are managing with 12 bytes. So just have a look, like if we are using Rajasthan, Delhi and Haryana in string format, that is going to take 42 bytes for maintaining this particular state level information onto disk. And if we are doing encoding over here, say dictionary encoding, and that can be managed with 12 bytes. So this is the betterment that is given by dictionary encoding, and it is possible because of the data is maintained in column format. If like we are having uh, data in row level format, then row based file format, then this particular conversion was not possible over here. Like that particular conversion was not possible. So because of this particular reason, like column based file formats are having better compression rate. This is like uh, this is an example how like we are performing the encoding, or how the compression is working. So inside the compression, we what we are doing, we are just encoding the data. We are going to change a particular byte, or a particular data into different format, or we are going to perform typecasting. And with the help of typecasting and all, we are able to minimize the size of that particular data in that format, so that like onto the disk it will occupy less space. So that is like row based file format and column based file format, and how like we are having better compression rate inside the column based file format. Just have a look and ask if you are having any doubt. Just have a look, all of you, just have a look and ask if you are having any doubt. Swati, Rohit, Shivam, Vandana,
Ashok,
Naresh,
I
Rahul.
just missed that number. So that how that 12 came?
So we are giving zero, like one, we are giving these, you can say, values. Say Rajasthan is converted to zero, value is zero, dictionary encoding. Delhi is 1 and Haryana is 2. Okay, we are just giving certain numbers, and each integer value is going to occupy 4 byte. These are nothing but integer value. So cumulatively, like previously, these particular Haryana, Delhi and Rajasthan was taking 42 bytes. Now what we have, we are using the integer values over here, 0, 1 and 2, and cumulatively 0, 1, 2 will take for 12 bytes, 4 byte each.
Yeah. Okay, got it. Thank you.
Okay. Rahul, Naresh, Vandana, Rohit, Shivam, Swati, any doubt?
It's fine,
No,
sir.
no.
Fine, Ashok.
Okay. So which file format is good?
Column based, sir.
Column based is good, huh? Okay. Okay. So let's have certain examples with respect to row based and column based file format. This is day 15. Let me close this. Row based file format. Examples. So probably you have seen, say, text file format. CSV file format, XML file format, let me mention format as well. Format, JSON file format. XML, JSON, text, okay, CSV, that is fine. So all of these are row-based file format. And if these are row-based file format, then there are two things. Two things. Say row-based file format are having what? Faster read or faster write?
Faster, right?
Faster, right?
Faster write. Perfect. So faster write is there. And if faster write is there, then slower read is there. So once like you are able to see, say text, CSV, XML, JSON, the very first thing that will come in your mind, that should come in your mind, that is like faster read or faster write. Okay. So if like something is, if row-based file format is having faster read, then definitely slower read will be there. Okay, because the data is maintained one after another onto the disk, and because of that particular reason slower read is there, and it will depend upon your use case as well. Okay, we are having this particular use case. So data ingestion, like we can have faster read, but like if certain queries are being performed onto this particular data, then what you need to do, you need to have faster write as well, faster write. So in that particular way, like we need to think in that particular direction, like which file format, in which file format I can write the data, I can, you can say, write the data onto disk, or uh, like in which format the user can query onto top of that particular data, because user is going to query onto that particular data as well. And one more thing that I'm going to say, let me try to give you, let me try to show you a diagram. So part one, probably in part one it is there. Mhm. Hmm. So this is the diagram of Hadoop ecosystem, and we are having certain tools for ingestion, certain for data analysis, certain technologies or stuff for data processing, and then exploration, workflow system, and NoSQL. Okay, and NoSQL is NoSQL database basically over here. Okay, and what we are having, like why we are having NoSQL database over here, because like if we need to query onto the data, okay, which is stored inside the HDFS, that is distributed file system. So we are querying based upon this NoSQL database. HBase is there. This is the default, you can say, database, where like no connectivity stuff is required. Like we are having a direct connectivity with NoSQL database, HBase, and this is based upon the big table. big table basically. So once this particular Hadoop was designed, so what was the initial stuff that was given by Google in terms of white papers? So they have suggested say MapReduce and GFS. GFS. GFS, that is nothing but Google file system. Google file system, and MapReduce is nothing but processing framework. Framework. Framework, or GFS, that is storage layer. Okay, so Hadoop was designed onto top of this particular stuff, and they were having a particular very famous database onto top of this, that is mhm, big table. Okay, so in the same fashion, like the Hadoop was designed, and over here just a little bit change is there. Say instead of GFS, we were having HDFS, and instead of like big table, they are having inside you can say Cloud Era Quick Start VM, we are having HBase. So these particular things, why we are having like NoSQL database, this particular NoSQL database, because like over here inside the HDFS, the data is stored in terms of files. Data is there in terms of file. Basically, partition files are there. If you are able to recall, once we are writing the data onto the disk, then par par file is there, partition files are there, or like if we are getting the output from the reducer, then reduce files are there. So data is maintained onto the disk based upon in certain files, and over here like we can have different formats as well. Just try to visualize the thing, why I am going to cover this particular stuff over here, because you need to visualize it. And over here you can have different file formats. The data which is maintained onto the storage layer, you can have different file formats basically. And you can have compression as well, different compressions. So the data is maintained onto the disk in different file formats. Now, in order to query onto top of this particular data that is maintained in terms of files, we are having certain NoSQL databases. Okay, NoSQL databases, because the data is available into different machines. HDFS is nothing but the collection of multiple nodes. The storage layer is collection of multiple nodes, and once we are having multiple nodes, then database will not work. So we are having certain terms. It's a database, data warehouse, data lake. Okay, and databases are of two types, say SQL and NoSQL. Okay, then data warehouse, data lake, and we are having delta lake as well. Delta lake, or lake house is also there. Lake house, so you just need to uh, like come with the definition, what do you understand with these particular terminology, you just need to come with uh, like you just need to go through with certain links onto the Google, and you need to conclude like what is the meaning of database, and if like SQL database is there, what is the meaning of that, what is happening inside the NoSQL stuff, what is data warehouse, what is data lake, what is delta lake, and what is lake house. So just try to go through with these particular definitions and take it as an assignment. This will be the theoretical stuff, but that will give you certain insight as well. So let me come back on to the point that we were discussing. So data is maintained in different file formats onto the disk, and file formats are playing a role over here. Okay, how the data is maintained onto the disk, that is perfectly fine. But in order to access this particular data, we are having certain databases. Databases, it can be SQL database and it can be NoSQL database. SQL database, like we need to have like say data in tabular for structured format. And once we are dealing with NoSQL, like we can have data into like semi-structured schema related informations, and in if like data is available in terms of files and all, then we will be able to tackle with the NoSQL databases. So that is fine. Like in order to have, or once we are utilizing the file format, that is playing a role how the data is maintained onto the disk. But it is not like say you will be able to access the data in a fast way. How it is maintained onto the disk, because like we will be able to apply different compression, and while reading we are just going to pick that particular chunk. And there are certain stuffs as well, like how to like utilize NoSQL databases, and how to like leverage in order to read the data which is into different file formats. So on to top of this, these NoSQL databases are playing an another role. So what I want to say over here, once you are saying that file formats are there, then that means like how the data is maintained onto the disk. Okay, based upon compression and all. So basically, like if you are using uh, column based file format, then definitely like the better compression will be there. There are certain file formats which are specially designed to have the better compression rate. So in this particular way, the data is maintained onto the disk, but to read it from that particular locations, we are having certain SQL and NoSQL databases. And at that moment, these are playing playing a particular playing a critical role. So we will be discussing those particular things, but you just need to go through with the definitions, like what do you understand with these particular terminology, and then I will drill these particular things and onto the next level, and then we will be able to understand. So to conclude, like file formats are playing a role onto the disk level, how the data is maintained over there, so that the read and write will be faster. Okay, so over here, like we are having row based file format, text, CSV, XML, JSON, that is like row based file format. And what we are having, faster write and slower read. Then there are certain you can say other issues, what we can say inside the row based file format. Say if we talk about this text file format, like there are certain characteristics and you can say issues with each one of these particular file format. We are not going in detail, but let me pick one, say text based file format. So inside the text based file format, what is happening, the entire data, say text file format, text file format, that is nothing but row based file format, text file format. So what is happening over here, so entire data is stored in terms of string. Entire data is stored in terms of string information, string. And like if we are having say integer values as well, that will be stored in terms of string. Okay, so if like we are having if we like just need to read this particular data, if we need to read from the text file format, and like integer information is there, then typecasting is required over there. Typecasting, like converting, typecasting, converting one format to another. Okay. uh, uh, you can take this particular example like student id2, like if we are running this particular query onto text based file format, then what is happening internally, typecasting will be done, because like we are going to mention say 2 in integer, but the text file format will not be able to understand 2. What it will do, it is going to convert that particular data, okay, into string to say integer, then it is going to provide the data with respect to that particular query. Okay, so typecasting is done over here once like we are performing the operations onto text based file format, text file format basically, which is row based file format. And typecasting is also very, you can say, costly operation. And maintaining the stuff into string, that is also, you can say, it is also, you can say, taking high space, say if we are having certain number, that is the integer number, it will be stored in terms of string. If it is stored in terms of string, then 1 2 3 4 5 6 7 8, so it is going to take 16 bytes onto the disk. But this is the integer number. If it was string and it is stored in 16 byte, that is fine, but this is the integer number, and like integer number are stored in terms of string and occupy more space. And if it was integer, so it was taking 4 bytes only, 4 bytes integer. If this number was integer, then it must have taken 4 bytes only, yeah. Okay, because of this particular reason, like entire stuff is maintained in terms of string. These particular file formats are, you can say, slow once we are performing the operations onto top of these particular data frame. Sorry, file formats. So once we are performing the operations with these particular file formats, then latency will be high, because each and everything is maintained in string and or text basically. And if it was it must have, like if it was maintained in integer, then it 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 was taking only say 4 bytes. uh, then the typecasting related things, those are, you can say, there in text based file format, because it is not able to understand the integer stuff, so typecasting is done, the text information is converted into the integer, and then it is able to serve. So typecasting is also a costly operation. So these particular things almost like available in each of these particular file formats, what I have mentioned over here. And because of these particular reason, these are like not preferred in the big data world. Big data world, like we are not saying that we can't work, we can work, but these are not the preferred, you can say, file formats for the big data world. And what are the different file formats or big data world file formats, big data world file formats, So what we are having uh, say different file formats. Say Avro is there, Avro. Then we are having say ORC, then Parquet. So another stuff like with respect to row-based file format, all of these particular file formats are non-splittable in nature, non-splittable nature. And what is non-splittability? So I have mentioned it over here, like file chunks, file divided into chunks, then performing operation on chunks, and then combine the output. That is nothing but splittability. So these particular file formats are non-splittable in nature. And once we talk about the big data world file format, so I'm going to cover like Avro, ORC, and Parquet. Although like there are many more file formats which are available in market, but say for the ORC, for the Hive, basically, once you are doing the data analysis on to top of this, so Hive is preferred the ORC file format, and Parquet is the default file format for Spark. So these you can say are well-known file formats, and let me cover these particular file formats one by one. And one of the you can say major characteristic, uh, as we are talking about like big data world file formats, so all the file formats are splittable in nature. Let me mention in this particular way: Avro, then ORC, and then Parquet. So these are big data world file format. So first one is say type, like uh, which type of file format is Avro and ORC and Parquet. So once we talk about type of Avro, this is row-based file format, row-based file format, and ORC is column-based, and in the same fashion, this Parquet is column-based. Now, then read. Okay, if the row-based file format is there, then read will be read will be slower or faster?
Slow.
Slower.
Low.
Slower. ORC is the column-based file format, so read will be
Faster.
Faster.
Faster. Faster.
faster. Faster. Okay. Then write. So Avro is row-based file format. It is write will be
Faster.
Faster.
faster,
Faster.
and over here it will be
Slower.
slower and slower. That is fine. So these are the characteristics, and the very famous characteristics, like all of these particular file formats are big data world file format and splittable in nature. Now Avro. So Avro is having say schema evaluation. We are like talking about these particular characteristics, what we have mentioned in the starting, like read, write, splittability. We have seen all of these are splittable in nature, schema evaluation, and compression. So schema evaluation, eval. So Avro is best with respect to schema evaluation. Avro is best for schema evaluation. Then this is a good, and this is also good. So Avro file format is the only file format which is providing best schema evaluation. And best schema evaluation, what is the meaning? Say if the incoming file is keep on changing, the schema is keep on changing, then it is able to tackle in a best way. Okay, so schema evaluation is best over here. For ORC and Parquet, that is good. Then we are having compression. So compression over here, it is good. Okay, and for ORC, this is the best. The name of ORC is nothing but optimized row column. Optimized row column. This is the only file format among these. I'm talking about these file formats. So that is having best compression. It is having certain things like delta encoding, uh, run length encoding, dictionary encoding. So certain encoding mechanisms are there which are working in a perfect way, and because of this particular reason, the the compression is best over here. This is the only file format which is providing best compression. Now over here, like, we are having better compression, say arc is having better compression. Then what we are having, say, huh, uh, compression, schema evaluation, read, write. Okay, use case, use case. So with respect to the use case, best for landing zone of data lake. Okay, so what is happening over here? Let me mention. Uh, So what is happening, like once we are going to ingest the data, once the ingestion is being performed, then we are storing the data on a particular location, say S3. S3 is nothing but data lake, or SDFS. SDFS is also data lake. So once we are performing the data ingestion, then uh, the data is moved onto the landing area of data lakes. Like data is landed over there. So what we are having, the schema is keep on changing over here, and once like the schema is keep on changing, then we need to prefer this avro file format, and this is best for landing zone of data lake, landing zone of data
So
lake
can you please repeat landing zone?
landing zone. Okay, so what we are having, data ingestion, and we are moving it onto the S3. Okay, S3, or you can say HDFS, whatever. HDFS, these are nothing but data lake. S3 is also known as data lake. HDFS is also known as data lake. These are nothing but data lakes only. So what we are having, we are just like over here, we are having a particular, say, directory, and in that particular directory we are ingesting that particular data. Okay, in this particular directory of as SDFS or S3, we are going to ingest the data. Now that particular directory is nothing but landing zone, because our data which is ingested is going to land over there. It is going to store over there. That is nothing like theoretically we can say landing zone or landing area of data lake where the data ingestion is being happening. Okay, the data is being updated over there. Like if we are having incremental ingestion related stuff, like we are going to increment data or going to append that, but the data on that particular directory which we have mentioned, and over there the schema is keep on changing, the incoming columns are keep on changing, then what will happen, like we need to have a certain file format which will be best for such type of scenarios. So in that particular case, the avro file format is being preferred, because over here, like what we need to do, Landing zone means over here we are collecting the data we are which is being ingested. Okay, so where we will get the information that the schema is keep on changing in that landing area only na. So this is best fit for that particular zone. Is it fine, Rohit? Landing zone is nothing where we
Yeah.
are
Yes.
updating the data or putting the data in S3 or SDFS. Okay, then
Okay.
okay, perfect. Then we are having say ORC file format. So with respect to the ORC, like once you need to have heavy compression, then you can prefer this ORC. ORC is the best fit for the compression. Like where you need to have high compression, okay, then you can prefer this particular file format. Then then the next one is Parquet. Once you are having nested data, okay, nested data. Once you are dealing with nested data, then you can use Parquet format. So what is the meaning of nested data? Say like we are dealing with list, we are dealing with say tuple, okay, tuple we are dealing with say array, okay, and say we are having different type of data types uh, in the incoming data. Okay, so at that moment like this particular file format is playing a good role. It is good in dealing with nested data, right? So at that moment we need to prefer Parquet file format. So that is the use case, like once we are having nested data, and at that moment we can prefer Parquet file format. Okay, another thing, say this is default for Hive and this is default for say Spark. Spark default file format is nothing but Parquet. Parquet is working best with uh, Parquet file format. Just have a look and ask if you are having any doubt. All of you just have a look and ask if you are having any doubt.
The Avro is best fitted with which one? Hive or Spark?
Best fit for use case na I have mentioned landing area.
No, so like ORC is better for Hive, like that. Avro is better for what? Spark, Hive, or what? What will be the scenario for that Avro?
Okay, default file format.
Mm-hmm.
You are asking.
Like you have written, ORC is better for Hive operation, and Parquet is better for Spark
No, no,
operations.
no, no.
Like,
This is the default file format.
okay.
Default file format. Okay, so this is. So with respect to the Avro, like it is not tied to a specific, you can say technology or file format or tool basically. So we can leverage Avro into different applications like ingestion, data storage. Okay, even in we can connect. This is the file format. Like if we are using Apache Kafka, we can use Avro file format over there because we need to land the data If we are using Hadoop, we can leverage Avro as well. Okay, so Avro is not tied to a particular specific tool or technology. So this is, you can say, a universal kind of file format. We can leverage it as per our requirement. Right. And probably like say nested, you might be having nested data. So say we are having certain information. Let me try to give you certain insight about the nested data. Mm, mm, say we are having say student one, and uh, say number, and this is say mm, uh, prepared topic, prepared topics. The student one has prepared say data base, and say uh, big data, big data, and we can mention in this particular stuff. Now say student 2 is there, and say we are having information, say topic 1, topic 1, and say ETL, and say topic 2 to ingestion, the processing. Okay, say student 3 is there, and student 3 has prepared say about say Spark. Okay, so over here, like inside this particular student data, what we are able to see, we are having certain student IDs, but the data is having nested data types. Say over here we are having a list, over here we are having dictionary, over here we are having a tuple. So once we are having data in the columns in this particular data type, like we are having different data types, then we can say we are having nested data. And once we are dealing with such type of data, then Parquet is the best suitable data, you can say, of file format, and we can leverage, and this is default for Spark as well. So definitely, like we are going to prefer this one. So this is like the theoretical stuff with respect to the file format, and from the interview perspective, it's very important. Like, and from the design perspective, like these are the design, or you can say product planning related questions, and what will be how we will be able to answer. Say if like we are having nested data, then which file format we need to prefer? Blindly we need to go with Parquet. If like we need to have the better compression rate and we are working with Hive, then which file format we need to have? ORC. If we need to like if we are looking for a particular file format where the schema is keep on changing inside the ETL process, then definitely we can go with the Avro file format. So based upon the use case, we just need to pick a particular file format, and then we will move ahead accordingly. Now, what you need to do, probably all of you are having that test data set. Huh? All of you are having test data set which I have shared yesterday. Huh? Is it test data set from the Titanic? Huh? Are you having that test data set?
No, no, Ashok.
No. Okay, let me share it with you all. Huh? So just have this particular data set, and what you need to do, I have shared this particular test .csv file. Okay, now what you need to do, you just try to write the output in Parquet file format. Huh? Over here we have written it in CSV. Now try to write it in Parquet file format. Huh? Try to do it. Huh?
Sir, please paste this one here.
Hmm?
Uh, Please paste this code in the chat box.
No, that is the simple one, like you are reading and writing only. Read API and write API. Nothing we are doing over here. Okay. Try to write. Try to do it.
Oh, oh, oh.
If you are not able to do, then let me know. At least try first. Hmm. Hmm. Is it done? Swati, Rohit, Shivam, Vandana, Naresh, Rahul, is it done?
So we need to read it into this CSV and write it into Parquet.
Yes, and you will
Yeah.
be able
So
to answer.
yeah, it's done for
You will
me.
be able.
So yeah. So
Uh-huh.
it is showing me like this output. Let me share.
Just share the snapshot. Huh? So, friends, what we are able to understand, like, say if we are having a particular file in CSV format, then we will be able to convert it into the Park. Yeah? Or if we are, if like someone during the interview is asking how to convert CSV file into Parquet, then like read it in CSV and write in Parquet, right? What is the output? How just share the output snapshot. The files inside the output directory. The files must have the extension .par.
This is showing in my output result, and I need to go to the file system.
Swati, Shivam, Vandana, are you able to get the outcome in Parquet format? This is very simple. You just need to use format Parquet in while writing the data.
Yes, I got it.
Okay.
To see this, so my file path like showing this. So in the last it is showing dot snappy dot
Yes, it is
parquet.
Parquet. That's what I want to say. Like snappy
But
dot
why it
Parquet.
is okay? So it will show like snappy dot parquet.
Snappy is also default, you can say, compression codec for Spark.
Okay. Yeah, actually, in I'm working in Databricks, so there is a different type of path that I need to show that.
Okay, no, just like if you are able to get dot Parquet, that is fine. I think like Swati has had faced such type of question in past, like if you are having a file in this format, how to convert it into different format, right? Swati, is it?
So by this way,
Yes.
we can convert any of the format into any of the another ORC or something else.
Yes, it is the way to change the format as well. And in other words, you can say while ingestion, over here. Say while ingestion, you have utilized say Avro format. Now you can read the data from Avro format, do the processing onto top of that and convert it into the Parquet, so that like there will be, you can say, faster read as well. Avro, like that was providing faster write, Avro faster write was there, and if you want to have faster read as well, then change the format while storing it onto the disk. So you need to think logically. Okay, so what about others? Vandana, Naresh, Rahul, Shivam, are you able to do? And Vandana, like, are you able to read the text
Doing good.
file as well? Vandana, okay, Rahula.
Hello, sir.
Yes, yes, Vandana.
Sir, for now, I am not able to generate that Parquet format of file. I mean, I'm able to read the file, but writing file is not giving me the output, desired output.
Is there any error?
Yes, there is.
And what about Naresh and Shivam? Okay, so try to do it. Try to do it after this particular session, and if you face certain challenges, then ping to me. Now
Okay.
we are having another data set. Just have a look. We are having flights data set, flights data, and over here, like we are having certain planes information. Just have a look, and this is the tail number, then year. This is something like say, as we are having registration number of cars, so we are having tail numbers of planes, so tail number is this, year is this, then type like fixed wing multi engine, then which one is the manufacturer of this particular plane, then model, engine, seats, speed, and turbo, like engine type, turbofan and turbojet, whatever. So this is the information with respect to the planes. Now I'm having another file, that is flights small. Small flights data is also there, and it is having say certain information, say year, like when it was scheduled, basically month, day, departure time, departure delay, arrival time, arrival delay, then the carrier information, tail number, basically the registration number of the plane, flights, flight, that is certain data, origin, like this is the origin, or you can say from where it was, it has taken off, and this is the destination information, arrival time, and then distance, hours and minutes. So this is the information about certain small flights. Now, what we are going to do with these particular data set, we are going to understand joins, joins in Spark. So we are having say tail num, this is available over here, okay, and tail num is available over here inside the planes data as well. So both of these particular data set uh, are having tail num information, and that is nothing but the reference point. So what we are going to do, we are going to like read these particular files as data frame, and then we will apply joins onto based upon like these particular data set, and there are different types of joins. We will go through with those particular joins. So let me try to read this particular data. So first, like what we are having. So small flights data, read format CSV, infer schema true, mode permissive, and this is the data, and I need to change the path. So the error was coming. Okay, so it has been the path has been modified. Let me read it. So first of all, I'm going to read the small flights data, and I'm trying to list top 20 records of these particular files. Okay, perfect. I'm able to read the records of small flights data. Let me read the planes information as well. Copy and paste and say planes information, planes data basically. Say planes data and planes data dot show, and over here I'm going to change it with planes data. Okay, planes. Let me do the execution of this particular data set as well. So the execution has been started, and what I have done, I have downloaded the flights data, and I have picked small flights data and planes information. Now I have imported these particular data set and created two data frames named small flight and planes data. Okay, so we are having the information about these particular, you can say, flights. Now inside the Spark, joins in Spark, PySpark basically, PySpark. So if we are talking about joins, then there are four types of joins. Join is nothing like joining two or multiple data frames. Data frames, that is nothing but join. Now if we talk about joins, then there are four types of joins: left join, right join, left outer, right outer, that is the same, inner, that is the default one, and full outer, outer join. Okay, so left join. So once we are going to have left join, then what will happen? It is going to pick all the records from say left data frame, then plus matching records from right data frame. Let me use df, and na will be towards left hand side. Okay. Then we are having right join is opposite to this. If we are having right join, so if it is going to pick all the records of right data frame plus matching records of left df or first df basically, left, and NA will be say right hand side, right hand side. Then inner join matching records from both of the data frames, matching records only. Then full outer join, what it will do, it is going to list all the records from both of the data frames. That is fine. So we are having this left data frame and right data frame. Sorry, we are having small flight data and this planes data. So join is very simple over here. Say small flights data dot join, and dot join what I'm going to join, say that particular right data frame, basically say planes data dot join planes data, mm, planes data, planes data, and uh, then what I need to mention, dot join planes data, then what I can have on what, on I need to mention the reference column, that is say tail number, tail number over here. I will be able to see tail num, on tail num, and then type of join, then type what it will be, say inner. Okay, so let me mention it, say join df, join df dot show. Okay, let me try to print it as well. So execution has been started. Type, not type, I think it's how. Okay, so just have a look. So previously we were having this particular data set, and this is the like small flight data, and this is the planes data. Now what we have done, we have joined both of these two data frames, and we are able to get the information. Like we are having, you can say, records from both of these two data frames, and inner join is going to give me the records, like matching records from both of these two data frame. That is fine. Now what do you need to do? So I'm going to share these particular files, small flights data. You are able to read the information from your, like you, what you have seen, how to read the data from both of these two, you can say, data from both of these two files, and then how to apply the joins. Now what you need to do, you need to provide me the information of planes or small flights. So small flights, uh, huh. So small flights, let me show over here only. So over here, like this will be the joint df. Once like joint df, now what you need to do, you need to provide me the information of small flights which are running with one engine. Okay, which are running with one engine. You need to do certain customization onto top of this particular stuff. Like onto the join df, you need to apply filtration, and just provide me the count, or you can say list of the planes which are having, which are running with one engine. Okay, so do this for me. Is the problem statement clear to all of you? Is the problem statement clear?
Yes.
Okay, what about others? Is the problem statement clear? Shivam, Naresh, Swati, Vandana, Rahul. So you need to do the filtration based upon join df. You need to apply filter. We know how to apply filter. We have seen. You just need to provide me the list of planes which are running with one engine, and this is a particular, you can say, typical use case as well. Like I'm having certain flights, small flights, and I'm having plane information. With respect to these particular small flights, in plane information, in planes data, I'm having engine related informations, like is this particular is like the small flight having, small flight having one engine or two engine. Okay, or you can say certain upgradation is going on, and the small flights which are running with one engine. So I what we want to, like, retire those particular planes, because we don't want the risk, and the small flights which are having one engine only, I just want to retire those particular planes. So you just need to tell me the small flights running with one engine. So is the problem statement clear?
Yes, sir. Yes, it will.
Okay, okay, perfect. Naresh and Vandana, Swati, Rahul, what about you? I have shared the data set, so work on that particular data set and provide me the information of small flights running with one engine. Is it done? Okay, so let me do it for you. Hmm.
Just a minute, Ashok, we are doing just.
Not an issue. So, what we are having this joint DF. Huh? So, on to the joint DF, what we can have, we can apply a filter clause, filter, and filtration based upon what? So, filtration based upon this joint DF, and inside joint DF, we are having a particular column named engine. So, engine column is there. Let me show you. Okay, so engines column is there. Let me mention the column engines column, and what I want to have engines, and I just want to have less than 2 engines. So that's it. Dot count. Dot count. So, and let me print this as well. Print this. Okay, so let me do the execution. Very simple, like onto the joint DF, I'm going to apply the filtration on engine column and selecting the engines less than 2 count, less than 2, and we are having 8, you can say, flights which are running with one engine. Let me try to list those particular flights as well from this particular joint DF, and say I am say fine tuned data, or you can say flights with one engine. Let me be more specific, flights with one engine. Okay, and okay, so flight with one engine and flight with one engine dot show. Okay, so this is the simple clause that you need to apply onto the joint DF, and you will be able to get the flight list which are running with one engine. And that particular hint I have given, like you need to apply the filter clause onto the joint DF where you are having each and every information. So, so these are the planes which are running with one engine. Like say the tail number is this one, which was built of which was like say built of this 1975. It's type of say rotorcraft and running with one engine. Okay, so I don't want to these particular engines in my, you can say, planes list, and I'm going to retire these particular planes. So that is what like we are having a particular use case with respect to the flights data. Okay, and what we have seen, we were having two information like flights, small flights data and plane information, and then we have joined both of these two data frames, and onto these two data frames we have filtered the from the joint data frame, we have filtered the planes with which we are running with one engine. Like less than two is definitely like one engine. So less than equal to, that means like it will list the planes running with two or less engine. Okay, so we are able to get the information now. Now, now, if I want to write this particular data on disk, then how it will be done? Probably each one of you, you are having the knowledge of data read and data write. Now try to write this particular data frame like flights running with one engine onto a particular location. Why I am saying so? Because you will face certain error, like if you are going to write this particular data frame, you will get certain errors, and how you are going to tackle those particular errors, that you need to tell me. Yeah, the error will be very like simple. Okay, say over here it will be, let me try to write it. So what I suggest, try to write this particular data frame by yourself. All of you, are you doing the practice, or you want like to the execution from my side? Swati, Vandana, are you trying it?
Yes, sir. Filter is done.
Filter done, then try
And
to write it.
yes, sir.
Try to write it on disk. Naresh, Swati, Shivam, Rohit, Rahul, is it done for you?
Yes, writing the output.
Huh. You need to tell me the error. What is the error? Yes, what is the error? Column already exists, huh?
Yeah, this error showing is for me.
So the column year already exists, huh? So just have a look over here as well, huh? Like year, year column is existing. So year is available over here, and year is available over here. So we are having two year columns. And once you are going to write the data, so just try to like keep this particular thing in your mind. You are able to visualize the multiple columns with same name over here, but
Yeah,
once you are going to store the output, it will throw error. So there are like multiple ways in order to tackle this particular situation or problem. Like manually delete this particular column. Okay, just like by utilizing drop functionality. But at that moment, like what will be happening, we need to have the exact column name from this particular data set, and we need to look of the entire, you can say, data frame, or we need to check all the columns, like which column is repeated, and say we will get that particular stuff inside the error. But uh, the manual deletion, like if two or more columns are repeated, then manually deletion of the columns is not preferred, not a preferred way. So how you are going to tackle such type of scenarios? So at that moment, like say we can have say unique column, say unique call equal to say call in column, call in say call in df dot columns dot calls columns, and if df dot columns dot count call equal 1. Okay, so over here what we are doing, we are trying to calculate the unique columns, try to find the you can say unique column. So we are what we are doing over here, we are iterating with columns, and we are like counting those particular columns, and when we are taking where the count is one only. Okay, so we are going to iterate with all columns. Flight dot call, like df dot columns, that is going to give you a list of columns. Let me try to print it over here, dot columns. So it is going to print all the columns which are available in this particular data frame. Say print. Okay, then we are iterating it with for loop, and we are finding out the count. We are selecting the columns where the count is 1, and we are assigning those particular columns to unique calls. And then what we are doing, we are uh, we are creating a data frame. So say data frame with unique column. You can say unique call df, unique call df. And what we will do, uh, just small flights data frame dot, we are going to select dot select, and we are going to select the unique columns only. All unique columns will be selected over here. That's what. And then we will write this particular unique call df to this particular location. So let me try to do the execution, then we will have discussion on to this. Over here like we are using this unique call, you can say calculation, and we are finding all the columns, then counting onto the columns, and the columns which are having count equal to 1, we are taking those particular columns only, and with those particular columns we are going to create a particular data frame. So these are the columns. So df dot, like flights with one column, one engine dot columns, it is going to give me the total, you can say, columns from this particular data frame. Then what I'm going to do, like I'm going to iterate it with for loop, okay, and finding the count of the columns which is having equal to 1, and then assign those particular columns to unique. Then unique, then inside this flights, you can say with one engine, I'm going to select these particular columns only and assign that particular value to unique df, okay, unique call df, and then finally printing that particular unique call df.
But so
Okay,
Ashok, I think
so
you put the condition on unique one data set only. So I think it should be on join this condition to be applied. Join data set.
no. Join DF is converted into flight with one engine. I have filtered it, and filtered is given to flight with one engine. So that is generated from the join DF only.
Okay, yeah, got it.
Okay. And now you will be able to see the output. Just have a look. And now what we are having? The flights running with one engine.
Okay, so after
And
making it unique, so data is saved.
yes, yeah, if you are having unique column, so with this particular functionality, you can have unique column. And this is pretty simple as well. Like you are selecting all the columns from this particular data frame, iterating it with for loop, counting, and where the count is 1, you are picking those particular columns, and then it will be given to unique call. So unique call is having, say, the column where the unique columns only, then you are applying those particular columns to flies with one engine, and then you will be able to get the outcome. Okay, unique columns only basically. Okay, so that is with respect to the joining, joins which are available inside the PySpark. Left, right, we have seen inner join. Now what you need to do, you need to like take it as an assignment. You need to work with left join, right join, and full outer join, and write your observation after applying a particular join. Like say I have applied inner join over here, inner join over here, sorry, left join, join over here. Then uh, you, what you need to do, you just need to share the observation, like how many records are there once you have applied the left join. Okay, the left, you can say, data frame was having this much of record, and once I have applied left join, then it has given me this much of record, and this is as per my expectation. So you just need to write the observation, because like it will give you certain insight in order to build your concept. Basically one or two questions will be there from the joins itself. The the interviewer will give you certain data set and will ask you what will be your output if you are going to apply left join. What will be your output if you are going to apply inner join onto these particular data set. So if you are having this much of clarity, like say left join is going to provide me this much of data and it is working in this particular way, so you will be able to answer the interviewer in a correct way. So that observation is mandatory after applying the join. Just try to write down your observation, take this particular thing as an assignment, and then in the next session we will have discussion onto the the other topics, visualization and all. Okay, and we will focus on to the middle component, that is nothing but the processing framework, like processing the data. Reading and writing, we have done too much operations on reading and writing. Now we will focus on to the processing. We will start the Spark SQL as well. Okay, how to process a data frame, how to convert a data frame into SQL like into a table, and how to apply SQL like operations over there. So those particular things we will cover in our next session. If you are having any doubt, you can ask. Let me stop recording.